So I wanted to record a little session on how to look at inodes. So I'll be alternating back and forth between these slides and a terminal. So the first thing let's look at is the df minus I command, which you can see I just executed. And you can see that it shows us how many inodes we have on a particular partition, how many inodes have been used, how many inodes are free. And this would apply to any individual partition. Let's contrast that with just the df command. So notice that my inodes that I've used up are 4% on that particular partition. And over here, my actual disk space, the blocks that I've used up, are 9%. So one of the test questions I like to ask is, can I run out of inodes before I run out of blocks? Yes. Can I run out of blocks before I run out of inodes? Yes. And so you have to be concerned about both of those. Anyway, ls doesn't access inode metadata, but ls minus l does. So ls just gives us the files that are in that directory structure, but ls minus l actually accesses some of the metadata which is in our inode, such as the date the file was last changed, modified, UID and GID, permissions, and some other things. Stat, if we do a stat on a particular file, like file1.txt, it will also access metadata information, that information that the inode is actually saving for us. Okay, so let's see, the other thing we want to look at is inodes when we are creating different links to help us understand it a little bit better. So let me create a symbolic link. And do I have one of those? No, okay. So ln minus s creates a symbolic link. This is kind of like a shortcut, but hopefully you'll get the idea here when I do it and how it relates to inodes. I'm going to link this to file1.txt, and my symbolic link name is going to be called to file1. And if we do a ls minus l, we can then see here is my symbolic link. So when someone accesses this link, it's really going to file1.txt. Now let's do ls minus li to see the inode number that we're referring to. So file1 is referenced by inode 401067, and the symbolic link has this inode number. So let's see what happens if I were to say echo blah 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 into to file1, and we cat out to file1. We see that content, and we'll also cat out file1. So basically, when I'm doing this redirect command, we're saying redirect it into my symbolic link, and my symbolic link is saying, really, just go over to file1 and put it in there. That's what a symbolic link is. Now let's contrast that with a hard link. So I'm going to create a hard link, and you do it the same way, but without the minus s. So the target, and I spelled file2 wrong, so to file2. All right, so as we look here, there's no fancy little arrow, so we know, well, we don't actually know it's a hard link. There's nothing that actually shows this, the hard link, unless we do this. Let's list our inodes. So file2.txt is referenced by 401069. To file2 is also referenced by 401069. So here's the tricky thing. Well, not tricky, but so just something else. So I'm going to put this into to file2, the hard link. Let's cat that out to file2. Great. Let's cat out file2. So since I'm redirecting it to that hard link, and that hard link says go over to this inode, which has a bunch of data blocks that says we're supposed to save the data, that's where it's going to be saved. But this file descriptor or name in our directory hierarchy also references this inode number. Hence, when I write it to one, or when I write it to this file, it's actually writing to this inode, and when I access this file, It's also accessing the same inode. So the final thing here is what happens if I remove, so ls minus li, what happens if I remove my file 1, my file that I was symbolically linked to? And let's cat out, so I'm just going to say, right, I'm accessing my symbolic link. Oh, no such file. Because if you look, oh, now it turned black because it's still pointing to a file called file1.txt, but file1.txt is not found. Okay, so that's bad. Let's see what happens if I remove file2.txt. Can I still access it through that hard link? Absolutely, because we can still get to that inode number. So, awesome.